It's all happened here. Everything we've ever known, done, loved, took place on this drifting, spinning ball that's our home. It's where we learned to provide, nurture, protect, thrive. And yet,
wildfires are scorching the West Coast, leaving behind a path of death and destruction.
15 inches of rain this morning.
The waters keep rising, and according to the National Weather Service,
our very success now threatens our future. Today, our greatest challenge is to learn how to grow while sustaining what sustains us. Your understanding, your science, your work are the solution. You have the power to see patterns and relationships and show us how everything and everyone are connected. You have the power to transform how we produce and consume, build and maintain, unite and strengthen, heal and nurture. You can help us see that we can no longer live apart from nature, but must live as part of it. Today, geography matters more than ever. The geographic approach, your work, and the billions of maps you make are essential for creating a more sustainable future.
Welcome to the 2021 New Zealand Esri User Conference. For more than 25 years, the New Zealand Esri User Conference has brought all the technology updates and trends from the Esri International User Conference to you, our local users. It is where we focus on you, your stories, your experiences, your industries, and your innovation. This year, for the second time in a row, we're unable to do this in person, as much as we tried. Instead, we're able to bring you all the content to you during this plenary online event and the webinars that will follow over the coming weeks. I'd also like to take this opportunity to thank you all for your continued support, and also during this year when we lost our leader, Coralie Eagle, and my mum. I really wanted to thank you for the messages that you sent me from all walks of life and all of our customers. It was really heartfelt, and it helped us get through a very tough time. So thank you very much. Eagle is financially very strong, and we are growing. And we're looking forward to helping you and support you through these next few years. I also promise to carry on and uphold the values that Coralie and Trevor started this company with. And I thank you again for your support. And now I'd like to pass on to a really good friend of ours, Jack Dangerman, the head of Esri, for a short message. Thank you and enjoy the show.
Hi, my name is Jack Dangerman, and I'm speaking to you from our new building at Esri in California. I have the opportunity to join the others in welcoming you to your users conference for South Pacific and New Zealand. I wish I could be there. I have enjoyed some wonderful times with you at your conferences over the years. Prepare yourself for some great presentations over the next few days, and also an update on our technology, the technology that we designed to support you in your various work activities. Before going into that, I'd like to acknowledge the passing of Corleen Eagle. She was one of my great friends in life and one of your friends. Her and her husband, Trevor, many years ago, when I was just a young boy, introduced so much of the IT culture of New Zealand to New Zealand. They were pioneering at IBM, working together as Prime Computer representatives and later Sun Microsystems. And then they started to move from hardware into software and IT services of various types. And they were an inspiration to me because they kept learning as they got older. They had a passion to be able to learn. And this is something that not only inspires me, but should inspire all of you. You know, we're living in a technical age where we need to have lifelong learning philosophy, and they exemplified it. Corley even in her last year, wanted dearly to travel to California to pick up the latest on how we were doing business and how the technology really worked. I dearly love her, and I dearly will miss her and her good spirit. This year, we've made many advances in web GIS and cloud GIS, in real-time GIS, and being able to see things in 3D and visualize our world in new ways. This is helping us in the frontiers of science, but also in practical ways of making things more efficient and more sustainable. It allows us to approach problem solving using the geographic approach. You know, the geographic approach is built on or enabled by GIS technology, but it's an approach which allows us to see the complexity of the systems that we live in, our world, human systems, natural systems. It allows us to see them and integrate them, to see the whole, to take holistic approaches, which are multi-participant, allowing everybody to participate, and integrative approaches, meaning we can bring all the different types of information together using geography as a common thing. And then, based on our digital sets, do various kinds of actions through your various applications. This field is growing enormously and very rapidly by being able to provide better access to the information systems that you are building with hubs and portals and web apps and pervasive apps that tell stories, things like the COVID story. This last year, we saw over 2 trillion maps made on the Johns Hopkins website, just talking to the world about what was going on with respect to the emergence and the spread of COVID. Well, we are challenged by other subjects like climate change and all of the implications that that has to us in loss of biodiversity or severe weather that's being caused around the planet. And you, as GIS professionals, are the people that can actually stand up and build the systems that I believe can help respond to these crises that we're living in. So I wish I could be there with you, and I really want to say thank you for picking our field. I think you picked a good field, and good luck in your work. Thanks.
Thank you all for joining us for this 2021 Virtual New Zealand Esri Users Conference. We would have loved to have been joining you all face-to-face across the country, but we feel that despite COVID restrictions, this is still an excellent opportunity to achieve the main purpose of the conference, as it has been for many years, namely to share the latest technology along with stories of the great work that you are all continuing to do across our region. This morning, we have over 600 registered attendees from all over New Zealand, as well as a number of attendees from overseas. We particularly want to welcome those of you who are joining us from the South Pacific. This morning, as we have said, we'll be sharing technology updates and demonstrations along with customer stories and examples. To give you all a bit of a break from your screens, we've split this morning's session into 2 halves with a 15-minute break at 10:30, and then some time to answer some of your key questions at the end at 12:30. As far as asking questions goes, you can type in questions throughout the event and the team will be replying as we go. Then, at the end, we'll be taking some time to respond verbally to the most common questions. There's a lot of information to get through this morning, and so to avoid us overwhelming you, we wanted to offer some resources for you to review following the event. These are resources such as deep dive technology videos, web pages related to this morning's topics, as well as links to some of our customer examples, and we'll be sharing links to this at the end also. While this is of course now a virtual event, we wanted to recognise those organisations who had supported the face-to-face event series that we had originally planned. You'll recognise many of them, and we want to thank them for their support and to encourage you to check them out in the sponsors section of the resources document. Before we look at the technology and how it's being used in New Zealand, I thought it would be useful to take a step back and look at the field of GIS, or geographic science. The use of location or geography to connect facts to linked observations and to gain insight into our world is of course nothing new, and has been going on in many forms for centuries. This of course doesn't mean that it's not still highly relevant today. In fact, it is perhaps even more relevant given the challenges that we face in every field and the access we have to increasingly complex location-enabled data and analysis capabilities. We can refer to this as a geographic approach, a way of thinking and problem solving that integrates geographic science and information. It's a holistic approach which brings together various sciences. It is also collaborative and multidiscipline. While simple in concept, this geographic approach can be used to unlock important insights and can be used to impact every sector and field, both at a local and a global scale. Analytics, visualization, design, collaboration, accounting. All of these methodologies have a geographic dimension which can be critical for decision making. The technology of GIS enables this geographic approach using digital data capture, computing power and interactive mapping to support a cycle which integrates geographic knowledge from data capture and measurement through to analysis and then to action. All of this is faster and at a larger scale than was ever previously possible. A large number of you as GIS professionals are of course using this approach and this technology to create powerful solutions for many different industries and areas of work. To support your work, GIS technology itself is advancing. These advances are possible in part through building upon innovations in mainstream IT and in part through specific work in the GIS space. Imagery is a very key one here. It is advancing rapidly, and so this can be both a challenge to stay current with new technology and an opportunity to apply it in new areas or at greater scale. A major growth area is the level of connectedness of our GIS systems. This is supporting collaboration, allowing more efficient workflows, better information sharing, and building on top of existing capabilities and datasets, such as using the Living Atlas and base maps, as well as being embedded inside other non-GIS applications. Underpinning this connectedness is a thing called geospatial infrastructure. And while this can be thought of as a layer on top of existing mainstream IT infrastructure, such as in the cloud or on servers, it's a very powerful thing in its own right, using shared GIS services to support many different applications, to connect our various GIS systems, and to support new workflows. These workflows and connections span teams, organizations, and are increasingly changing the way in which these groups of people interact. Now is an exciting time for the expansion of these capabilities, with many powerful GIS apps and data being shared. Local applications and global applications are being used at scale to support many different communities. And by scale, we mean tens of millions of datasets with billions of maps and users. The lifeblood of this infrastructure is to a large extent the data that flows through it. One of those rapid advances in technology has been the inclusion of new types of location-enabled data, which can be integrated, such as for analysis or visualization, and all brought together into a geographic context. This being a key part of the geographic approach. Imagery is growing rapidly, both in terms of its availability and the ability for GIS systems to store, analyze, and extract information from this imagery. And we'll hear more about this later. The other key types of data include BIM formats, real-time data, and rich multidimensional datasets. All of these datasets are then abstracted into web maps and 3D web scenes, so that they can be published once and then used across many different applications. These apps are of course the way that people interact with this information, whether it be on mobile devices, web browsers, or powerful GIS desktop software. These applications are no longer just for GIS professionals, but are very widely deployed and used, especially web and mobile. Another way in which this key spatial information and insight is being consumed is through embedded apps. This is an area where Esri has worked with organizations such as Amazon, SAP, Microsoft, Salesforce, Autodesk, and many others to include these maps and other GIS capabilities inside an existing application, allowing many more users to take advantage of this geographic approach without the need to be a GIS professional or even indeed knowing how to spell GIS. And complementing this is the enrichment that's happening as a result of advanced GIS analytics, allowing us to see new things, create new insights, and make predictions. These are possible through accessing data sources such as multispectral and hyperspectral imagery, and rich data sets combining space and time. Increasingly, this data is being stored, accessed, and analysed in the cloud, for example, in ArcGIS Online. Big data is here and has been with us for a while in the world of GIS, whether we're accessing data from transactional systems or from sources of imagery. ArcGIS provides the ability to integrate data from these massive data sets, which will in turn open our eyes, allowing us to see relationships that we could not see before. I mentioned imagery as one of those big data sources, and over the last few years we've seen a massive increase in both the availability of high quality raster data and the power of tools used to manage, manipulate, and analyse these data sets. The data itself comes from satellites, aerial capture, and drones, and even terrestrial sources, while the uses for this imagery range from creating compelling base maps as context to your work, through to carrying out advanced analysis, for example on multi and hyperspectral imagery, unlocking the hidden information in these images. We'll be taking some time throughout this morning's session to look at just some of the variety of work being done across New Zealand in different industries, all of it by you. I want to share with you first some examples of local government organisations working in the area of community engagement. Taupo District Council recently partnered with Eagle Technology to upgrade Taupo GIS to ArcGIS Enterprise 10.8.1 and at the same time implement Local Maps 2.3. This combination has introduced fully flexible tools enabling TDC's geospatial analysts to quickly and easily produce targeted applications for staff and customers, including integration with their new ERP system and the use of more 3D applications. We will hear more about the rollout of LiDAR for New Zealand shortly, but I want to take a moment to show you the beautiful story map that Waikato Regional Council have created, telling the story of this programme for the Waikato. Queenstown Lakes District Council have recently made available their new Spatial Data Hub, built using a combination of Hub and Experience Builder. This provides an easy-to-use, intuitive web app for accessing various forms of data, including hazards, historical imagery, and property information. The Wellington City Council's Spatial Plan Story Map is being used as a blueprint that helps to guide and communicate the vision for the future of Wellington, a very powerful tool. Planning, designing, and developing our future urban spaces is a very complex task involving many different parties. We're seeing GIS used as a key tool to both manage the sometimes complex data sets involved and engage the communities themselves. The Omakura Peninsula near Tauranga has been recognised as a future urban development area. Over the past months, Western Bay of Plenty District Council have been using ArcGIS to communicate, consult with residents, and leading to the development of a structure plan which will accommodate the region's growing residential development needs, while also providing for the community's future aspirations. GIS also underpins the Wellington Housing and Business Development Capacity Assessment, which is completed by the councils of Wellington's major urban areas. GIS collaboration was used this time in order to better connect the different councils involved across the region. Piritahi is an alliance of the companies formed to speed up the supply of build-ready land. They're working within Kaingaora's large-scale urban development areas where state-owned land is being prepared for new homes along with upgraded infrastructure, parks and public spaces. Piritahi use ArcGIS mobile apps and dashboards to provide key stakeholders with real-time visibility on the status of houses marked for removal, ensuring they can be relocated or sustainably deconstructed as efficiently as possible. Alongside these specific examples, Eagle are working with a number of New Zealand councils right now to use ArcGIS Urban and City Engine tools to plan for the future, work being undertaken in support of New Zealand's Urban Development Policy Statement. New Zealand's built assets are worth many billions of dollars, with over $60 billion planned to be spent on infrastructure alone over the next 5 years, Planning, designing, building and operating this vital infrastructure is a highly complex job, and GIS underpins many of the different aspects of this work. And we wanted to share just a few examples with you here. These include ArcGIS being used for operating and maintaining the assets efficiently using real-time dashboards. Also raising public awareness of investment plans, as well as electric lines companies sharing vital health and safety information about their overhead lines. Also, we're seeing organisations streamlining the import of new data through efficient as-built data import mechanisms. And finally, using the tools to collaborate with stakeholders using BIM data, in this case here, using 3D scenes to share information on a new building development. Finally, in the area of forestry, an industry which has been using GIS for many years, we're seeing innovative uses of the latest ArcGIS tools. Indafor are using satellite imagery and dashboards to understand and share information on the changing patterns of forestry and harvesting across New Zealand and Australia, providing near real-time information to support a range of environmental planning and strategic decision-making processes. Another innovative use of data captured from above comes from Hancock Forestry, this time from helicopters, where they have vastly improved the quality and efficiency of aerial surveying for tree diseases by using ArcGIS Quick Capture. The operator quickly records observations through the corresponding buttons, which automatically store coordinates, offsets, and direction of travel. Processed quickly in ArcGIS Pro to create a forest map, which is then used to identify where and how much to spray. I'm told that alongside improvements in data quality, moving digital is also helping a lot with serious air sickness for operators. Like many modern technologies, the ArcGIS system has a rapidly evolving suite of capabilities. And since we last met, there have been a number of key developments that we want to share with you this morning, while also providing a bit of an overview of the system as a whole. Data is the lifeblood of all computer systems, and this certainly is the case for GIS, where a combination of your own data and geospatial content provided through Eagle and Esri gives the context and support for your own amazing work. Eagle's work in this space is growing to provide additional, richer and more advanced content. To tell us more about this, I want to hand over to Boudewijn and Callie.
Today, I would like to talk to you about what's new and coming in ArcGIS Living Atlas for New Zealand. For New Zealand, a wide collection of data is available. Base maps in NZTM in a variety of styles, census and boundary data from Stats New Zealand, OpenStreetMap layers and 3D layers like the New Zealand elevation layer. The layers in ArcGIS Living Atlas are available across the system in ArcGIS Pro, ArcGIS Enterprise and ArcGIS Online. And you can also access these layers in apps like ArcGIS Insights and in geo-enabled apps like ArcGIS Maps for Office. And the great thing is that they can be used for analysis as well without the need to download the data first. You can, for example, use any of the boundary layers to aggregate your own data against. A very popular set of layers are the base data layers, contributed by Land Information New Zealand. And LINZ has started contributing to the Living Atlas with some very useful layers, like addresses, building outlines and parcels. And the latest additions are the Fire and Emergency Localities layer and the New Zealand Facilities layer that shows the schools and hospitals. An important change that LINZ has made to all their layers is that they have changed the portal the data is hosted from. This means that the URL to the layers have changed, and if you're using the old layers, LINZ encourages you to change them to the new layers before the old ones stop working by the end of the year. And the new layers are now available in ArcGIS Living Atlas. You can also find boundary layers with data sourced from Stats New Zealand, and these include administrative boundaries, urban and rural indicators and statistical areas. With the 2021 update, we have now added items that will be updated yearly as new data comes available. So they have the keyword current added to the title, and this makes it easier if you always need the latest boundary layers in your project. For the New Zealand schools and early childhood education layers that hold a lot of detailed information about these facilities, we have enabled daily updates, so that when you use these layers, you are always working with the best available data. For our users in Fiji, we have an update as well. Last year, in cooperation with the Bureau of Statistics in Fiji, we released the census data for the provinces. And this data is available in ArcGIS Living Atlas and will find its way to Esri's demographic layer real soon. And this will mean that that the data will be available in the geo-enrichment tools and in ArcGIS Business Analyst, allowing you to create beautiful infographics. Base maps are an important part of almost any map, and Esri and Eagle have a variety of maps available as raster and vector base maps. And for a raster base map, we have published a new set of base maps that all use the same updated tiling scheme. And that new tiling scheme allows you to zoom in to 1 in 70 for all base maps. And the old set of base maps now have the keyword classic added to its title, and we encourage you to start using the new ones. And 3 of our current raster base maps have now moved to mature support, the good old community base map and the canvas base maps. And they will remain available but won't be receiving any data or style updates, as we now have vector base maps available as well. And the community base map did receive a final update a few weeks ago. The focus was on refreshing the roads and labels, as well as update the other data in the map. But again, this was the final update to this map, so whenever possible, we encourage you to switch to the vector base maps if you haven't done so already. There are also some significant updates to our imagery base map, and to take you through those, I'll hand it over to Kelly, who is currently an intern at Eagle Technology.
Now I'd like to share with you an exciting new tiling schema of our New Zealand imagery base map. This new allows users to zoom into 1:70 scale compared to 1:282 with classic New Zealand imagery. To demonstrate this, we will explore the water and wastewater pipelines in Wellington region. With this classic version scale, it's hard to identify close features. For example, these 2 pipelines as shown on map. Now, with the new version, which allows you to zoom in closer and make it easier to identify features that are located close to each other. This new New Zealand imagery base map also had another update recently. We have added bathymetry to it. So we have a more appealing looking map, especially when looking at it on smaller scales. Even though using an imagery base map can be very useful, it can be hard to navigate as you might miss contextual information like place names, roads, and street names. That is why we have released the New Zealand imagery reference layer. This vector base map is designed to be overlaid on top of the imagery, giving more context to your map. Because it is a vector base map, it allows you to customize the style. With this base map, we also publish a metadata layer available in ArcGIS Online. This layer shows the data we use in our base map, but we realize it can be a little tricky to identify the imagery is actually shown because of overlap of older and newer imagery. That is why we are currently working on an updated metadata layer that make it easier to see what data is showing in the base map. We will also introduce some tools like this dashboard to easily visualize, search, and filter datasets to show the currency and resolution across New Zealand. These are the new changes we have made to our New Zealand imagery base map. Now I'd like to hand it over back to Baldwin.
Thanks, Kelly. Those are some great updates, and a massive thanks goes out to Alice Mill as well. She's the newest member of the content team and has been working on both the bathymetry update and the new imagery reference layer. And finally, I would like to talk about 3D. With all the great elevation data that is available and all the data that will be coming out in the next few years, Eagle has decided to provide a New Zealand elevation layer. And this layer was previously in pilot phase, but is now part of ArcGIS Living Atlas. And this layer is the base layer underneath your base maps to show all the hills and dips that make New Zealand so amazing. And this layer is in NZTM, so it works with all the New Zealand base maps, but the elevation data will also be added to the world elevation layer later this year. Hopefully that gives you a good view about the ongoing work we're doing in this space. To learn more about the layers that are available, you can visit livingatlas.arcgis.com.
As you can see, there's a lot going on with content, and in fact we'll hear from the LINZ and regional councils a little later on about the national elevation work based upon LiDAR data that is being captured and made available currently, as well as how Eagle are working with that data to make it directly available to you within ArcGIS without the need for downloads or LiDAR processing. Another content area that we're looking at is localized premium imagery base maps, augmenting the data that's publicly available with premium sources. So please get in touch with your account manager if this would be of interest. ArcGIS Online is Esri's SaaS or Software as a Service product, and is used by millions of users globally every day. It allows you to store and manage your data, as well as to create maps, analyze data, and easily create compelling apps to share with your users. Because ArcGIS Online is hosted by Esri in the cloud, it scales automatically and receives automatic updates several times each year. To tell us more about what's new in ArcGIS Online, I want to pass over to Lauren McCartney.
Hi everyone, ArcGIS Online. I'm going to be taking you through what's new in Esri's Software as a Service mapping platform. Today we're starting things off with your homepage. The homepage editor was introduced last year, and it's awesome to see many of you grab the opportunity to add your own individual flavour. Organisations can now configure fonts for titles and body text on their homepage, and you can choose a preset font theme or create your own custom font combination. And this really helps to build a tailored and enticing front end for your users. The great thing here is that the new homepage is also mobile responsive, and this is something that the old homepage wasn't. From your entry point to content to building up your content, getting your data into ArcGIS Online is a key workflow, and it serves as a foundation for everything that follows. From my content, there have been some small changes. Clicking New Item will reveal a redesigned entry point for anything that you want to add, from file-based items to URLs. So I'll drag and drop a CSV of species observations. As you add your content, you'll see that ArcGIS Online now automatically recognises my file type without me explicitly identifying its type. I'm then taken through a more stepwise presentation, making it easier to understand what information is needed to ensure this item is added correctly. And as we all know, making sure to fill out the item details is so important to make your content clean, discoverable and manageable. So assigning those categories, adding some informative tags, which now is not mandatory, but it is incredibly important to do so, and it will make your life easier down the track. And then add a summary. Now I think it's fair to say that many of us really start our data visualization and exploration with web maps. And the new map viewer and general availability since April, Esri are continuing to build on and improve this new web mapping experience. Now if you haven't already, you must check out the redesigned pop-up experience in the map viewer. It gives you so much more flexibility over the content that you display, in this case creating a nice, clean, to-the-point pop-up about species observed at Nelson Lakes. Building up your map, there are now 2 more supported service URLs you can add. This is OGC API features and tile layers. But let's focus on sketch layers. These were released a bit earlier this year and are great to provide more ad hoc detail to your maps. In this case, it could be a quick scribble outlining the areas where observations were scarce, yet the location via the tracks here was easily accessible. Now this sort of annotation is ideal for planning or review sessions to improve for the next program run. And scale visibility can also be applied, so there's no overcrowding. With a variety of draw tools and over 1,000 symbols, the options are pretty endless to create your own graphics, to those serious, and then also just fun maps, like this map here of the Te Araroa Trail that covers 3,000 kilometres down the length of New Zealand. Here I've used some more pencil style stamps and added text from a huge range of fonts to build a tailored vintage style map. The benefit of this being a web map is that it can then be shared into an application, whether it's an instant app, a story map, or even a dashboard. Another cartographic tool that's being enhanced in the map viewer is blending. Now you might have heard a bit about blending already this year. Essentially it gives you greater control over what shows through and how colours and textures appear between layers on your map. Here we're looking at ethnic diversity in Auckland using the predominant smart mapping style, and I also have the LINZ building footprints. So from this you can see the footprints and you can see the census units, but it takes a second to connect them. Using blending, I can select the census layer and choose the source in blend mode. This takes my building layers and my census layer and applies the symbology to the footprints, allowing the base map to come through, taking away the noise and making a more useful product. Now beyond demographic data, think of the applicability of this to other information, like hazards. Like in this case, looking at what buildings could be impacted by a future tsunami, and what zones do they fall within. Or you could be looking at buildings that might be at high risk of being damaged in a flood return event. The style reduces the noise and adds a level of detail that can sometimes be missed when purely overlaying zones or other polygon feature layers. Moving now to charting. Like maps, charts help uncover patterns, trends, and relationships in your data. In this case, we're looking at crowdsourced weather observations over time. Now this map is fine. It shows me the high density clusters where more weather events have been observed and documented, and I get this updated when I zoom in. But for this data, the map probably isn't enough. Seeing each region compared, I would get a greater sense of trends or disparities in climate events across the country. Clicking on charts, we have 3 types: bar charts, histograms, and scatter plots. I'll create a bar chart looking at the event type in each region. Also, if you have created a chart in ArcGIS Pro that's one of these 3 supported types, it'll be carried across into your maps in the map viewer. Now, new in charts is the ability to sort, where I might choose y-axis descending by value. I can also select data on the chart that reflects on the map or exclude some weather event types if needed. I can also update the series, as right now I'm still not getting a good picture. So first I'll look at stacked, but as this is crowdsourced information, it is skewed by population in each region. So the best option probably is the 100% stacked, which removes that bias and lets me see each event type as a proportion of the total events in that region. And with the ability to rotate charts too, I can now present this in different ways. Also, a hot tip, if your layer is being continuously updated, then you can also now set a layer refresh interval in the map viewer. Finally, let's move to the 3D realm. In the recent release of ArcGIS Online, there was a major milestone for the scene viewer, editing point, line, and polygon feature layers. Now here we have a web scene of Wellington City using the Council's freely available 3D buildings, planning zones, and other contextual layers. And as you may have picked up, the scene viewer has a similar UI design as the map viewer. You have expandable icons on the left where you can access scene layers, slides, and properties, but in this case I'm going to use the edit button to add a proposed building to the site. But I'm going to start in a 2D view, just so you can see some of the new snapping capabilities. In this case, we're going to be looking to snap to the perpendicular and parallel lines of the boundary of this parcel. Now when we move back into 3D, I can use the new editing handles to transform my building. I can move it around, I can make it bigger, I can move it up and down, rotate it, and align it on this parcel. And then once I've got it to the right position, I can then continue to add more features and edit existing features as needed. So that was just a taste of what's available in ArcGIS Online at this release. Keep an eye out for what's going to be available in September to see what Esri are going to be bringing out next.
ArcGIS Enterprise is a key foundational component for WebGIS, with many organizations using it to store the data, maps, and host applications. More and more organizations are utilizing Enterprise alongside ArcGIS Online to create a more complete set of capabilities. For example, supporting solutions which need to have data stored domestically, or which require more complex integration to other non-GIS enterprise systems. Like ArcGIS Online, ArcGIS Enterprise is a rapidly developing technology with new features being released on a regular basis. To tell us more about what's new in ArcGIS Enterprise, I want to pass over to someone who's responsible for managing this awesome piece of technology and who's familiar face to you as he was here with us in New Zealand at our New Zealand Esri User Conference 4 years ago. This is Esri's Philip Heady.
Hi, my name is Philip Heady, and I'm the lead product manager for ArcGIS Enterprise with Esri in Redlands, California. I wish I could have been with you in person today. I've had a chance to join you a couple of times in the past for the New Zealand Esri User Conference, and I can't wait for that to be possible again in the future. For now, I want to thank the entire Eagle team for inviting me to record this short video for you today. I'll spend the next 5 minutes or so to go over some of the highlights and focus areas for ArcGIS Enterprise development for the past year, along with a look at the coming year. We've already had one release in 2021, and it was ArcGIS Enterprise 10.9, which was made available in early May. As always, there were many new and updated apps and functionality throughout the software, but there was one major new introduction that I want to speak to for a little bit. And that is, of course, ArcGIS Enterprise on Kubernetes. This was a major milestone in Esri's investment in building a modern and truly cloud-native deployment option for ArcGIS Enterprise. It's a new deployment option that sits alongside our existing software on Windows and Linux, and it was designed from the ground up to use technology patterns such as containerization and a microservices architecture. It runs today on Kubernetes engines in the public cloud, such as Amazon's EKS and Microsoft Azure's AKS, as well as Red Hat OpenShift in your own private cloud or hybrid cloud environments. In the next release, we're also adding support for the Google Kubernetes engine within Google Cloud. ArcGIS Enterprise on Kubernetes is designed for organizations with existing Kubernetes skills and investment that have larger deployments with high availability requirements. I highly encourage you to check out the relevant sessions from the Esri user conference of a couple of months ago if you're interested in more information, and of course to speak to the Eagle team if you have any questions. Next in 2021, we'll be releasing ArcGIS Enterprise 10.9.1 near the end of the year. This will be our next long-term support release on Windows and Linux, and I highly encourage all of you to make this your next upgrade target. Not only are there a lot of enhancements as always, but it is also a very important release for other reasons that I'll get to in just a second. First, though, I want to talk a bit about a couple of the bigger changes and enhancements in 10.9.1. There are a lot of things going on in the ArcGIS Enterprise space right now. As we continue to develop and invest in the future, we're also preparing to let go of some of our past. As part of that, ArcGIS Enterprise 10.9.1 will be the last version to support publishing services from ArcMap. It will also be the last release where services that were originally published from ArcMap will run unchanged. The Enterprise 10.9 series includes migration tooling that will help you move existing services that were published from ArcMap so that they will continue to run on future releases. Some services may require additional work. That means even if you've fully moved to using ArcGIS Pro in the past, you may still have older services that were published from ArcMap and are affected by this migration need. This is something that I highly encourage you to start planning for now so that you're ready in 2022 when ArcGIS Enterprise 11 is released. There are several blog posts and a white paper already available to help guide you through this, and I'm sure the Eagle team will also gladly work with you on any questions. On the side of providing new exciting functionality is the inclusion of the new map viewer with Enterprise 10.9.1. This is a completely new and rewritten version of the map viewer, based on the latest technology for improved rendering and performance. It has a new intuitive look and layout, and a lot of work went into taking the experiences of the past many years into account in the application design. You'll see more immediate feedback when filtering and symbolizing data, more flexibility and options for pop-ups, new smart mapping styles, new symbology, and much more. And based on the feedback that we've heard from many of you, the ability to finally use group layers in your web maps will be very much appreciated. It's exciting to be able to ship the new map viewer as a built-in and fully supported part of the Enterprise portal in 10.9.1. Next, I want to highlight the upcoming support of what we call cloud data warehouses. This is the new breed of data storage options such as Google BigQuery, Snowflake, AWS Redshift, and similar types of data warehouses, often available in cloud and cloud-like environments. This support is another prong in our concerted investment in cloud-native technologies, and something that I'm also very excited to see come into the product. In ArcGIS Enterprise 10.9.1, we will initially be supporting Google BigQuery. In fact, the team is also hard at work on Snowflake and AWS Redshift support, but we're still waiting to see if that will be ready for 10.9.1 or if it will have to wait until the next release. When you have one of these cloud data warehouses, you'll be able to create a connection using ArcGIS Pro and work with the data using query layers in a way that's very similar to other more traditional databases. That means you can write a SQL or SQL-like query to define the subset of data you want to draw on the map. As part of that, you can enable binning in order to more easily visualize and interpret the potentially huge data sets that these data warehouses often contain. You can even take snapshots by extracting a data subset to be stored locally within ArcGIS Enterprise for longer-term storage or interaction. This is only the first release of functionality, and we have even more plans around this for the future, including both support for new data warehouses as well as functionality for how to interact with them, including things like feature service support. This will be an interesting area to continue to look at in the future. This was really a quick tour of just a few highlights, and of course, there's much more. The ArcGIS Enterprise product team continues to invest broadly in both framework-level enhancements on Windows and Linux, cloud-native capabilities on Kubernetes, as well as Windows and Linux, incorporating new apps, and delivering cutting-edge new GIS capabilities. I really appreciate your time today. I wish you all the best, and I hope to see everyone soon. Thank you.
Web applications are where the majority of users experience GIS, whether powered by ArcGIS Online or ArcGIS Enterprise. There are a number of options for delivering these web applications to your users, and as many of you know, choosing the right app is fundamental to creating a great user experience. To take you through the latest web application developments, as well as the considerations for selecting the right options, I want to pass over to Ed Cook and Julian Pilwa.
WebGIS is continually growing, with new applications being developed to not only leverage the latest technology, but also to meet our ever-evolving expectations of effective data communication. For many of us, this communication begins with a map and a question. However, to our surprise, we quickly find that a map cannot solve all the world's problems. This is where many of you have configured web applications to further describe your data, to help inform decisions, perhaps provide narrative, or even initiate a conversation. However, the challenge we are now facing is with access to so many powerful applications, which one is the best tool for the job? So today, Ed and I are going to guide you through the who's who in the zoo of ArcGIS app builders and why you may use each one. And to get us started, let's take a look at Instant Apps. ArcGIS Instant Apps are the latest generation of Esri's configurable apps, and as the name suggests, are the quickest way to transform your map into an audience-ready application. Not only are they great for adding context through descriptive text or simple widgets, but they're ideal for scenarios where time is of the essence. Let's take a look at how you create one. So here I am in the new map viewer, and we have a map showing buildings in Auckland within tsunami evacuation zones. And as you may have seen in the ArcGIS Online demonstration, you can easily create instant apps from directly within the viewer. By clicking the button, the Instant Apps Builder is launched, where you can browse a number of pre-configured templates, ranging from sleek, map-centric templates to capability-focused ones, such as Lookup, Nearby, and the new Portfolio and Countdown templates. In this example, I'm going to choose the Media map. And as you'll see, with no more than 5 clicks, I can create a simple map with a legend, which is ready to be shared or embedded within a website. Now let's take a look at how we can help inform decisions using ArcGIS dashboards. Dashboards play an essential role in many of your organizations. They are interactive, easy to configure, and provide dynamic real-time visualizations. Not only do they allow you to reveal hidden trends within your data through the use of charts, but also report on key performance indicators at a glance. In this scenario, I want to understand the number of households within each tsunami evacuation zone and use this as a tool to inform emergency services. Dashboards have a number of ready-to-use elements such as lists, charts, filters and indicators, so let's quickly build an indicator to summarize the number of households within the yellow evacuation zone. And after duplicating and resizing my indicators, my dashboard is starting to take shape. Now these indicators can be static, but their light truly shines when you connect them to your map, and so as your extent changes, so do your metrics. Whilst the dashboard may be ideal for one audience, it may not be for another, as not everyone is interested in numbers and figures. Enter ArcGIS Story Maps. Story Maps enable you to support your map with a narrative through the use of text, images and videos, all wrapped up into one compelling linear interface. They've become enormously popular, regardless of whether you're constructing a report, a blog, a tutorial, or even a guided tour. In this example, we have a story map answering the question of how do I prepare for a tsunami? Story maps have become increasingly more configurable with the ability to create custom themes, navigation bars, and even express maps directly within the builder. And whilst I wouldn't recommend the use of story maps as a fully fledged website, they can make for excellent standalone web pages where integrating spatial information paints a more cohesive picture. So that's Instant Apps, Dashboards and Story Maps. I'm now going to pass over to Ed to talk about app builders.
App builders are making it easy for users to build their own apps, creating an environment where there is no code or low-code app development. This is where we are taking widgets and web maps to build web apps. Experience Builder is the next generation of web app builder and is more optimized for mobile environments. It also has mapping visuals powered by the latest version of the JavaScript API. It comes with a variety of templates for you to build your shell and get started, and you can even create your own. Once underway, it is simple and straightforward to access and embed your ArcGIS content. The whole screen is your real estate. The possibilities for user interfaces and the resulting multi-page experiences here are endless. Experience Builder is the most configurable out of all the apps. To finish your work, you save your changes and then publish, allowing by default a parallel development and production version of the app for you to work with. Another question we often get asked is what crowdsourcing options are available in the apps? What if you need a platform and website for an initiative in order to persuade and have a two-way exchange? ArcGIS Hub continues to evolve with added functionality, including the ability for administrators to create and author surveys inside the app for the audience. With Hub, you can create an initiative website to persuade, inspire change, and boost engagement around some of the challenges your organisation is trying to tackle. You can surface and embed content, such as the experience we created earlier. This allows geospatial data to be at the centre of understanding. But it isn't just one way. In the latest release of Hub, it brought the ability to author and publish, and also embed survey forms without even having to leave the app. This allows your audience to have a data-driven conversation around the initiative that they care about. Conversing via surveys as part of an overall engagement strategy is something that Hub can enable. So whether you have one app by itself or a daisy chain of applications as you see here, there are many ways to make your data shine. Both ArcGIS Online and ArcGIS Enterprise have a variety of different apps available. This allows you to maximise the use, how you present and communicate your data to others. In the past, we've tried to include as much as possible inside a single web app. But now going forward as a user, ask yourself the question, what is your app attempting to answer? What functionality do I need? And you'll find the right app or set of apps for you and your users to take GIS to the next level.
Earlier, I spoke about geospatial infrastructure. This concept that a key aspect of WebGIS is about geospatial data and capabilities being made available very widely using secure web services. How this data in particular can be shared has advanced greatly in the last few releases of both ArcGIS Online and ArcGIS Enterprise, with a number of options and considerations for those looking to collaborate across teams or even organisations. To take us through these options, as well as to share some of the latest developments, I want to pass over to Ed Cook again.
Our work is interconnected. Every task relies upon both coordination and collaboration, and the tools that we use can help us to be more effective and efficient in how we do our work. So, as an individual using GIS in their day-to-day work, what drives us to collaborate and share? Perhaps it's a necessity for a task, or a desire to enable others with the content you have created. Whatever our reason, it creates a need to share our geospatial content wider than just one machine, allowing others to either view or benefit from use of it. There are many ways to share content within the ArcGIS system, and the two concepts that enable this are groups and sharing permissions. When we combine these, we can generate various workflows to help you share your content. Sharing permissions within ArcGIS Online and ArcGIS Enterprise give you the ability to share content to anyone, whether it's the general public, your organisation, to a specific group, or just you. If we are needing to share to a specific audience, this is where we use groups. Groups are a collection of items usually related to a specific area of interest. You can create groups as a way to organise and share your items into a collaborative workspace. As a group owner, you can decide who can find the group, who can join, and who can contribute content. You also have control over items shared with the group, and you can also invite others to join. Once a group is created, you can easily add items. You can also add users to your group. You do this by searching across organisations for the specific members of your team. You can do this so long as the profile you are looking to add is public. Once the invite has been sent, the user in the other organisation can still choose to join. Hopefully, if they choose to accept, they can then see the group and the items that have been shared with them. Following this, they can go further and even view and interact with them, even if they are hosted in an external organisation. So the benefits here are clear of being able to look at data and interact with it that isn't a static cut. It's a live data set coming from an external organisation that then they have the ability to take and add to their products. So what if we need more options, such as quickly finding a member of an external organisation when an admin isn't around? Well, this is where collaborations come in. Collaborations are a technical configuration and based on a foundation of trust between participating organisations. Two types of collaborations can be established with other organisations. If using ArcGIS Online, partner collaboration like you can see here, and distributed collaborations for enterprise. Your ArcGIS Online organisation can use partner collaboration to share content with other ArcGIS Online organisations. When you enter this partnership, it creates a formal handshake. And this allows two admins from different organisations to delegate day-to-day coordination with other users, but also tracking at a glance which organisations they are collaborating with. You can assign what's known as a collaboration coordinator, which is that delegated day-to-day manager role. They can add users to and from groups and also add in additional items of content that may be relevant to the specific project. And this happens on both sides. So one thing to note here that is the fact that groups and membership are unlimited, but with partner collaborations you can have a maximum of 10 with different organisations. And when that partner collaboration ends, both organisations lose access to each other's content. But the benefits of being able to escalate group settings is a clear benefit of choosing this option. So what happens if we're using Enterprise? Well, distributed collaborations are a different method purely for enterprise-related collaborations. And they can be useful for many workflows, including exposing ArcGIS Enterprise content to the public through ArcGIS Online, or making data visible across different departments. To share content in a distributed collaboration with other organisations, an administrator begins by creating the collaboration in the collaboration workspace. They then link a group to that workspace, and then invite participants to the collaboration. The organisation that creates the collaboration is the host, and other participating organisations are the guests. As with partner collaboration and groups, both administrators have to accept the invites to establish this more formal sharing pathways. So collaborations can be useful for many workflows. And as you can see, there is no single pattern for collaboration. So you can choose to implement it in a way that suits the best of your needs. So as you can see, there are many ways to share content within the ArcGIS system. And the two elements that enable these are groups and sharing permissions. When we combine these with partnered and distributed collaboration, there are various workflows available to help you share your content. Which one you choose depends on your content and business needs. These workflows can enable you to share anywhere, anytime, to help integrate our knowledge with anyone.
Real-time data sources are increasingly available to us, and many of these have a location. Whether it be an object or person changing status, location, or both, this is a rich data source for us to integrate within our applications, not only for alerting in real time, but also to analyse the large amounts of data created over time and to identify patterns and trends. While we've had an enterprise-based application for this in the form of GeoEvent Server for a number of years, Esri recently added to the ArcGIS Online extension to support these capabilities as a SaaS with ArcGIS Velocity. I want to pass across to James Wright to take us through ArcGIS Velocity, a complete real-time GIS delivered as SaaS.
Today, real-time data and information is becoming an integral part and expectation of a comprehensive GIS. To deal with this growing demand, we need a solution that can deal with these massive amounts and high velocities of data. This is where ArcGIS Velocity comes in. Velocity is a real-time and big data processing and analysis capability of ArcGIS Online. Velocity uses distributed cloud processing to scale tasks, enabling you to ingest, visualize, analyze, store, and act upon IoT sensor data. The Port of Napier are interested in creating a real-time operational picture of their port. The port have a data stream of all the nearly 80 forklifts around the port. To monitor their whereabouts, we need to create a feed. This data feed could be coming from live locations of vehicles using messaging brokers such as MQTT, or cloud platforms such as AWS and Azure. We can then light up our maps with a stream layer, or even just a feature layer. With those feeds now set up, we want to run some real-time analytics as the data is streamed in. The port is particularly interested in certain areas where forklifts are not meant to go. Using this intuitive and easy to use analytic builder, we can easily run our new feed through a series of actions. In this case, we want to use the detect incident tool, where we'll link the forklift feed with the port no-go polygon layer. Now, whenever one of our forklifts intersects with that area, we want there to be an action. In this case, we want the event to be captured in a feature layer, and we also want to trigger an email notification. If the forklift had some sort of dashboard inside the vehicle, we could also trigger an internal notification directly to that vehicle by using one of the message broker outputs. Now finally, before we see what this all looks like, there is one final component, and that is big data analytics. Over time, we will start to amass large amounts of data. This is where we can use the distributed processing power Velocity is built on. Analytics can be run on millions or even billions of records, like in this case with years worth of forklift history, with over 4.5 million records. The analytics allow us to periodically pull valuable analysis on things like roading condition, hotspot locations, and incidents over time, to name a few. Now let's take a quick look at all this data together in our live operational view of the Port of Napier. In this operations dashboard, we have our live stream layer of the last load locations of the forklifts, giving us great insight to its whereabouts and status. This simple data stream can have benefits to both efficiency and safety when you understand where heavy machinery may be operating. The dashboard also allows for the viewing and filtering of the big data analytics previously calculated. We can see which individual forklifts are consistently traveling inside no-go zones. This may help to realize where to put more signage or marking in a certain area. We can also analyze trends over time, such as where our hotspots are for forklift activity. This allows us to monitor and understand areas where road surface wear may be higher and act accordingly. We've shown only a few data streams, but the port aims to add streams such as vehicle fleet tracking, electricity meter monitoring of critical infrastructure, and even locations of valuable containers. All of this will help the Port of Napier to realize its goal of a digital twin of the port, and Velocity is a key piece of the puzzle that allows them to do that. I'm looking forward to seeing how you all start utilizing real-time data inside of your own organizations.
ArcGIS Pro is the world's most powerful desktop GIS. Used by tens of thousands of GIS professionals across the world, it is a key part of WebGIS, allowing users to access powerful desktop editing, cartographic and analysis capabilities while closely coupled to web-based capabilities. These capabilities include machine learning, which can be used, for example, to analyze and extract features from LiDAR, an area that we'll hear more about shortly. Like all aspects of the ArcGIS system, ArcGIS Pro has multiple updates each year, including new functionality and the quality enhancements. And so I want to ask Hannah Jones and Megan Chong to take us through some of the latest developments for ArcGIS Pro.
The latest updates to ArcGIS Pro focus on visualization and productivity improvements. Today, I'm going to briefly introduce you to some of these new features. First, I'm going to share some of the new enhancements made to visualization. I have here a school zones boundary layer for the City of Auckland, and I am interested in areas which fall within the most school zones. But the way it is currently visualized, it is not clear where the overlap occurs. To draw attention to the overlapping areas, I'm going to use the new feature blending tool, which blends together overlapping polygons in the same feature. For this example, I'll select Color Burn, which intensifies colors in areas of greatest overlap. So if you want to have a greater choice of schools for your children, then finding a house in this darker area could be ideal for you. To understand the location context of my map without having to increase the transparency, I can then apply layer blending, which combines characteristics from different layers so I can see both the underlying labels and color burn effect I applied shine through. By experimenting with feature and layer blending, you can imagine that the possibilities to visualize your data are almost endless. As I click on different school zones, the default selection outline makes it difficult to interpret my selection when unselected features are surrounded by selected ones. To make this clearer, I can now choose to apply a fill color or hatch pattern to selected polygon features. The next visualization tool is something that you former ArcMap users might recognize. The eyedropper tool is a way to quickly pick a color from anywhere in my map and apply it to a layer's symbology, in this case, New Zealand schools. This ensures a more cohesive and consistent look and feel. Finally, I'd like to share a new feature that will enhance productivity across various workflows, the command search bar. This new capability allows me to search for any tool, command, or help documentation and quickly execute it directly from the search results, such as enabling labels. Command search is context dependent, so it will only show the relevant commands depending on what is selected in my map, all while minimizing the number of clicks and tab switching I need to complete my tasks. This was a quick tour of some of the visualization and productivity features added to the latest release of ArcGIS Pro. Now I'm going to pass you on to Megan, who will show you a new way to explore and prep your data with data engineering.
Thanks, Hannah. As geospatial professionals, a lot of our work deals with data, and sometimes that data needs to be explored and prepped before we can use it in our workflows. The new data engineering experience in ArcGIS Pro provides a better way to dive deeper into the characteristics of our data and apply different tools to it so it's analysis ready. Let me show you. I have that same New Zealand schools layer that Hannah had shown earlier. I can right-click the layer in my Contents pane and open up Data Engineering. In the Data Engineering view, I can see a list of all the fields in my dataset and its type. Now there are different ways to explore data. At the spatial level, I can update the symbology of my layer field by field to get insights into spatial patterns. For instance, there is a greater concentration of single-sex schools in central Auckland. Another way to explore data is through charts. I can quickly create a bar chart of any categorical field to visualize its distribution. The third way to explore data is through statistics. I can select the fields I want, drag and drop them into the right, and click Calculate. Here I now see chart previews to better understand the distribution of my data, as well as powerful summary statistics like mean, median, the number of nulls, all the way to more sophisticated statistics like skewness. As I scroll through the list of fields, I notice a typo in the field European, so I can right-click and access the Clean tools to update the field name and correct it. Another thing I notice is some inconsistency in my roll date data. Looking at the statistics, it appears the minimum value in this field is from 1899, which does not align with the rest of my dataset. Because I don't want this to skew the results of any analysis, I can select the rows that correspond to the minimum value and replace them with nulls. By right-clicking the field, I can access tools to quickly run on the rows that I'm interested in replacing. I'll recalculate the statistics, and now we see that the minimum date, chart preview, and the number of nulls has been updated to reflect a cleaner dataset, ready for analysis. Data engineering's visual and interactive interface helps me to quickly dive deep into my data and quality check it while giving me access to the tools I need in one easy place. I encourage you to start leveraging it today whenever you receive a new dataset. With a myriad of new functionality released and more to come, I'd like to draw your attention to the fact that ArcGIS Pro now provides the same core functionality as ArcMap. I know some of you may still use ArcMap in your workflows, but it's important to understand that ArcMap 10.8, which is the current series, will be the last series released by Esri. In 2026, ArcMap will be retired, meaning it won't be possible to purchase new licenses or receive technical support for it. In addition, the ArcGIS Enterprise 10.9 series will be the last to support publishing from ArcMap. With that in mind, now is the time to migrate your projects to ArcGIS Pro. We have compiled a list of migration resources and more information for you, which you can access by scanning the QR code. That was a quick tour of ArcGIS Pro's new features and a reminder to start migrating to ArcGIS Pro if you haven't done so already. Stay tuned for later as I'll be highlighting some of the upcoming features in the road ahead.
As you can see, there's a lot going on within the latest releases of ArcGIS. We're going to come back to look at some more of the latest technology, as well as what's coming in a little later on. In New Zealand, we're very lucky to have access to a great deal of publicly available geospatial data, whether cadastral data involving parcels, demographics, and many other types. One fundamental data set which we use every day is imagery, a data set which quite literally allows us to see the land where we live in incredible detail. This imagery data, which is inside the Eagle base maps, was made available through the hugely successful collaboration between councils and LINZ, capturing and making available national imagery for all of New Zealand. Now, building on top of this work, LINZ and regional councils are working to deliver a national elevation data set based to a large extent on LiDAR data being captured and processed as we speak. To tell us more about this programme and what it means for you, I want to pass across to Andrew Ferrell from LINZ and Glenn Clarkin from the Bay of Plenty Regional Council.
Kia ora, my name is Andrew Ferrell and I'm from Toitū Te Whenua Land Information New Zealand, and today we're going to talk about the National Elevation Project, and for most people that would be the LiDAR project. And with me today will be Glenn Clarkin from the Local Government Geospatial Alliance and Bay of Plenty Regional Council. So where did we start with elevation? So it actually goes back to the Topo 50 maps, or the 50K topo maps that were produced years ago. And from that, we produced a lovely set of 20-metre contours, which were the national default for elevation for New Zealand for quite some time. And people used to use this regularly for lots of stuff. Obviously not good enough for the demands that we need now. So people took those contours and turned them into elevation products, and they started trying to use those and found that they were great for visualization, but not much more. And so what LiDAR will bring is it'll bring us to a point where we can get DEMS that are derived from LiDAR. And the difference in detail is staggering. This is a bare earth model of the ground. So, but you also have the ability to bring on top the surface features. And these are the buildings, the vegetation, etc. And so we're into a really different world where we can start to do modeling, etc. from these lovely bits of information. Also looking to make sure that the point clouds are available for everyone. And so this will allow people to use the point clouds to take out classifications that they want: buildings, vegetation, bare earth, lots of different things. And there's so many uses for this data. So here's just an example, imagery. We all know imagery, and we all know how good imagery is, but this is what we call a relative elevation model, which makes the river, the Manawatu River, the 0 point. And so when you do a LiDAR scene from that, you actually can see the dynamic nature of our braided rivers in New Zealand, and you can see where the historical channels were, potentially future channels, but you can just see the low-lying areas in relation to the river, which is fantastic for flood modelling, etc. So the National Elevation Programme will get us air-based LiDAR DEMS, DSMs, and point clouds, like I said. And again, like a lot of the projects that the councils have been working on in the regions and LINZ and central government, they will be released under Creative Commons 4.0. So everyone will be able to use them. And that's part of the success of this, is we need people using this data. Also, it's going to be nationally consistent. So we're releasing these all in a standardized vertical datum, so vertical datum 16. So if you jump from region to region, you don't have to deal in the different local datums that used to exist. There'll be a consistency of the data. And so we're spending a lot of time QCing that data to ensure that it does meet that specification that we've set out there. So where are we? Right now, we are, if you look on the one with on the left, we are at a point where there's actually a lot of data out there at the moment. A lot of this is data that we've been releasing over the last couple of years. But the big picture here is that we're moving towards, at the moment, we've got contracts, etc., signed by councils and regions that will actually get us to 80% in 2024. So this is the stuff we know at the moment. So this is really exciting. There is lots of data coming, so be ready for it. So it's not about data that is coming, because there's a lot there. And what I suggest is keep an eye on the LINZ Twitter feed, the LDS, sorry, Twitter feed. It's for the data service, because every time we release data, we will be putting out images so that you know that it's there. And this is just the images over the last year and a bit of data as it's released by the regions on the data service. And it also, the point clouds get made available on the OpenTopo, which at the moment, which allows you to download the points as well. And now I'll pass you over to Glenn Clarkin from the Bay of Plenty Regional Council.
So one of the great things about the National Elevation Program is that it's a true partnership model between central and local government, and that's through all phases of the project, right through from the funding and the planning of the work, through to the procurement of the data itself, the project management, and right to the stage we're at now, which we're looking at realising the benefits of this really powerful information. So it's fair to say that the Provincial Growth Fund application a couple of years ago really enabled a step change in how quickly we could capture this data. So it just meant that work that would have taken probably a decade or so to capture the 80% of the country that we're looking at has we're going to manage to capture that by 2024. And it also meant that we were kind of worked together, and all of the councils and LINZ worked together, and so we're not delivering this data in an ad hoc fashion like may have occurred. So the Provincial Growth Fund application really recognised the potential economic value of LiDAR to New Zealand. It's already used in a number of industries where an accurate understanding of the environment is critical to how they operate. So forestry's been using it really in quite a sophisticated manner for a number of years. There's flood modelling and flood risk, obviously, but there's also areas such as precision agriculture, which has really started to take off in the last couple of years. So from the initial $23 million investment, last year an economist, Aaron Schiff, estimated that if we increased issues around access, awareness and capability, New Zealand Inc. stands to gain up to an additional $36 million per year in economic benefit to the economy, as well as achieving better environmental outcomes. But the key here is around improving that access, awareness and capability. So really, making it easy for people to find the data, to access the data, and to make sure they've got the skills to use it as well. So one of the projects that the councils and LINZ are working on together is Elevation Aotearoa. So this aims to centralise all the important and useful stuff about the program, what data is available, what capture is underway, how you can access it, and it also has some learning tools such as case studies and how-to guides for getting started with LiDAR. So at the moment, it's, all the users of this conference will be familiar with. It's just a simple tab story map, but we're hoping to build on that in the coming months and years. So one of the main components of Elevation Aotearoa site is the availability and release schedule. So basically it just breaks down all of the data that we've got planned over the next few years into what's available now, what's coming soon, and where the collection is in progress. So it includes information around some metadata about the information. It's the area captured, when it was captured, the point density, the datum, as well as direct links to the data to download. So the DM and the DSM from the LINZ data service, and the point clouds from Open Topography. It also includes what's coming soon, so that businesses in different sectors can plan for data that's coming, and the rest of the information is the contracted projects that are scheduled to take place. It also includes information around case studies about how people are actually using this information in the field, and we're really keen to hear from people about their case studies and what they're using LiDAR for, because we hope to build this up and really improve the capability and understanding of LiDAR in New Zealand. There's also a couple of other sections around if you're new to LiDAR, around how-to guides and getting started with the basics. And we really hope to build this up as well over the coming months and years. And with that, I'll pass you back to Andrew.
Thanks, Glenn. I think the most important thing about this whole data set that we've got is the value comes from people using it. And it's not just the councils, it's not just central government, it's everybody here really needs to take up the challenge of using the data because we get the benefits from people using it in all industries. So take the data, use the data, tell us about the data. And I think this is where this partnership comes in really well. Central government want this to happen, local government want this to happen, and our friends at Eagle want this to happen. And that's where they're going to come and they're going to show you and tell you how you can use this data in the Esri stack and how you can actually get some value out of it.
As many of you have heard, building upon the fantastic work being done by LINZ and the Regional Council, Eagle are committed to making this initiative successful, including in the areas of accessibility, awareness and capability. We're doing this in 3 key ways. We're incorporating all of the elevation data into the Eagle New Zealand Elevation Service. As soon as it's made available, we'll be including this for you to use for visualizing 3D scenes, for slope and visibility analysis, and so on. We're also working with the folks at Esri to have this data incorporated into the global elevation services for use, for example, if you're working in a global map projection. Secondly, in combination with Esri, we're providing a set of tools, including deep learning capabilities, to allow you to work with the raw LiDAR data, for example, for extracting features such as trees, buildings, or power lines. And we'll hear some more about this later on this morning. Thirdly, this data opens up a huge set of opportunities for GIS applications across New Zealand. And we want to work with you on telling the stories of the great work that you are and will be doing. And on that front, watch this space for some exciting news soon. Before we come to the break, I want to look at some more examples of your work. GIS allows a whole range of network analysis to be undertaken, whether using driving or walking networks or both. Here are 3 examples of networks being used to solve problems related to travel. Wellington City, looking at how people can access the whole of the city on foot. National Map, analysing access to recreation areas such as beaches or parks during lockdown, allowing everyone to stay local but all still get exercise. And water and chemical distribution company Ixom, working with National Map to use ArcGIS Navigator for their drivers, providing an in-cab application to optimise their job routes and still adhere to the complex Max 50 road restrictions for larger trucks. As always at this conference, we take some time to recognise the vital and increasingly innovative work done by those using GIS to better respond to emergencies. Here we have just 5 examples. Some of these are public, some are behind the scenes. Some sophisticated, and some incredibly simple. The one thing that they all have in common is the powerful information that they convey to decision makers, including the public themselves. I want to particularly recognise the award-winning GRIP application from Auckland Emergency Management, an application enabling our biggest city to cope more effectively with emergencies of many kinds. I know that, like myself, many of you are enthusiastic outdoors folks, and so I'm particularly excited to see our next 2 examples. Firstly, the Mountain Safety Council are raising awareness of avalanche dangers through an engaging and data-driven story map. And secondly, the Walking Access Commission are providing everyone with a neat, native mobile application allowing walking access information to be seen for the whole country on and offline. Check out their Pocket Maps mobile application for Android and for Apple. The last couple of examples I want to show are simply beautifully crafted 3D views, both of the Christchurch area and both based on publicly available data. We will specifically look at how 3D capabilities in ArcGIS have progressed a little later on. That brings us to the end of part 1. We'll now take a short break and see you back here in 15 minutes.